Welcome to Closing the Loop, a podcast presented by Lakeside Process Controls, where we connect you with experts, end users, and suppliers in the industrial automation industry. My name is 𝗬𝗓𝗘𝗏𝗧𝗏, Business Unit Supervisor at Lakeside and your host of the show. Each episode will be featuring special guests from either Lakeside, Emerson Automation Solutions, or other industry leaders. And we hope that through these conversations, we can quite literally close the loop between your current knowledge and the latest advancements in industry. Our goal is to educate you and provide you with ideas for improving both efficiency and safety throughout your facility. Today we have a special guest joining us from Emerson's Automation Solutions team. His name is James Green, and he's the Canadian Sales Manager for FLEXIM Non-Intrusive Ultrasonic Flow Meters. Say that 10 times fast. James joins us through the recent acquisition that Emerson has made of FLEXIM's technology about a year and a half ago now. And James is going to explain to us, quite frankly, why Emerson acquired them. What is it that FLEXIM is doing that is so unique and so differentiated that their technology has been growing at the rate that it has been growing at, which has been pretty significant. So I'll explain to you how the technology works, and most importantly, for those of you listening, where you can position this throughout your facility. So there's many challenging applications throughout your plant, and maybe they can be solved with FLEXIM. Maybe not, but maybe. And so in this podcast, you'll have a little bit of some knowledge after about where you can and cannot apply this technology, and it might excite you at where it can be applied. We're even going to talk about the name FLEXIM, where this comes from, and being invented in Berlin. You're going to learn some unique German expressions, as James likes to say. So I really enjoyed this conversation. I hope you do as well. I hope you learned something from it. And most importantly, before I forget, please don't forget to subscribe so you never miss an episode. And with that, let's dive in. Welcome to the show, James Green.
Appreciate it. Thank you very much.
Thanks for being here. I am really excited to finally have you on. Pretty sure this is episode 12. That's about the time when you finally made the cut that you're allowed on it.
The truth does, I've been told hurt.
Yeah.
But it's good to know you finally made it.
Yeah.
Late round draft picks turn out okay.
Yeah. We had to make sure, you were with Emerson for a while, you were vetted, and then you could finally come on the show.
I cannot believe I passed the vetting process with Emerson.
Flying colors. Flying colors. You just had to live in Canada. That's all they needed.
Blood tests, just a quick, check on the credit score.
That's
your
awesome.
Firstborn son.
Yeah,
here we are.
Basically. So welcome to the show. Thanks for being here. For those listening who don't know you, which would be a surprise, but let's say they don't know you, James, maybe you could just introduce yourself, a little bit of your background, your expertise.
Sure. So my name is James. Last name Green is in the color, as my dad would say. Been with FLEXIM now for 3 years. Been with Emerson for almost 1 year. My purview, my position was the regional sales manager. So under that umbrella term that gets kind of thrown around a lot, it was on the technical side, it was on the support side, sometimes installation, being kind of like a little more on the customer-facing side. So it's kind of a larger, let's say, cast. And, it was one of the reasons is because I was the only employee in Canada. So you've probably heard me say when I go to a customer, right, that I'm, there's only one of me for 4.5 time zones in this beautiful country. So I think one of the reasons why I've kind of fit into the glove of what Emerson is in Canada is because we're such a solutions-minded sales org, pretty much across the country. So that's kind of how I like to liken myself. For me, I didn't even envision myself being a part of a sales. I went to school actually to be a teacher. And then, everybody in my family is a teacher. So I guess I would be the black sheep, for lack of a better term. But I think that some of that, wanting to be on the educational side, wanting to help, wanting to be, comfortable in these kind of situations kind of helped me get down this path.
Totally.
And, everything happens for a reason, as they say. And as my mom would say, I've monetized my mouth. So that's thanks, Laura. Appreciate you. Look, I made it. It's been really fun. Like you said, I'm really happy to be here.
That's awesome.
You've heard me say this before, but being part of the Impact Partner Network. When I was on the outside, you kind of look at the Impact Partner Group, and they're like the Yankees, right? Because they're everywhere.
Not like the Maple Leafs. That's
not like the Maple Leafs,
but the Yankees. Yes.
Yeah, the Yankees. I went with an adage that everybody in Canada doesn't have a scar tissue, I guess, with.
Yeah.
But being part of that group, and once you come over and you start putting on the pinstripes, you're like, oh man, these kind of fit nice. And I don't mind it over here. And you kind of start to, work through some of what you see and then what you actually get to see behind the scenes. And it's just been like incredible.
That's awesome.
So for me, it's been the best year I've ever had. It's been really exciting, and I'm looking forward to the next year. So thanks for
fantastic. Yeah. It's funny what you say about, going to school to be a teacher, right? That's where I feel like there's a big part of the role, and like being able to take a complex subject, something technical, and explain it simply and help everybody understand.
Yep.
And not everybody's going to need to be an expert on non-intrusive ultrasonic.
Yep.
They might need to be vaguely familiar or just know how to get it working for some of their applications.
Yeah,
so
sure.
They're not going to be in it every single day like you are, knowing all the nuances. So to be able to simplify something, I found that to be like an incredibly valuable skill set. So it's a different form of teaching, right?
Yeah.
But it's still education.
Yeah.
Right?
It all comes together at the end. So yeah, it's been really great. I'm excited for this. I'm excited for the Emerson acquisition, which hopefully we're going to be talking about. Excited for the next, couple of years as we start to kind of find out where we fit within the Emerson line card holistically.
Totally.
And for me too, right? We've spoken about this, obviously not on the podcast, but just at length, is one of the biggest things that's been a boon for us is because now we have all these other options, right? Where, when you look at every problem and you look at customers, challenges, sometimes not every solution is going to be this technology or this, way of solving the problem. And right. And so now, when we, I say we, Emerson, I've already been a doctor, look at that. But when we go and we speak to, anybody, right, we're really taking a look at that whole solution side of things, which is, I think, one of the reasons why I've enjoyed it so much is because you're not going in there and really positioning one thing over another. You're going and positioning something that's going to help the customer out the most, right? So that's been the best.
Well, that's the old adage that, you see everything as a nail if you're a hammer.
Yeah.
Right?
Yeah. That's the one of two German expressions that I say.
Oh, is that right?
Yeah. It's the, we'll talk about that later, but one of the famous German things that I heard is that why we're in so many industries is because all we had in our tool belt was a hammer. So every problem to us was a nail in one way or another.
Yes. So that's perfect segue. Let's talk a little bit about that. So for the people who aren't listening, FLEXIM was acquired by Emerson basically about a year ago now. I'm not sure when the podcast will go live. It's maybe over a year, but maybe can you talk a little bit about that, like who FLEXIM is, and why Emerson bought them, and what does that mean?
Sure. I mean, again, as the purchasing happened, it kind of came out a little bit of left field.
From your perspective?
From my perspective.
Okay.
And then you start to kind of learn a little bit more about what Emerson has been kind of doing with FLEXIM for the better part of like more than 20 years almost, it feels like, is that it's like, it felt fast and very abrupt to certain people, but then once you get a couple of layers above maybe where I sit, and I like to say I'm font 4 on the org chart, you realize that this has been something that's been kind of coming for a long time.
Definitely.
There's a really smart person that we work with. His name is Mark, and he talked about the expansion of scope, which I think is a really great way of talking about why FLEXIM kind of fits. Is because there was a kind of, let's say, a deficit or a void in the line card, right? Where we fit really well.
For the Emerson portfolio.
For the Emerson portfolio,
exactly.
Where they didn't have something like us, so we're not trying to displace maybe something that's already been there.
Yep.
Opening up a brand new kind of vertical for them, adding the FLEXIM, which is a clamp-on ultrasonic meter. So we use, a couple different measurement propagation techniques, basically across the board. We do clamp on the outside of the pipe, right?
Yeah,
so
non-intrusive.
Non-intrusive. So, we are able to do volume flow. We can measure, gas, liquid, steam. We can look at, hydrocarbon measurements, concentration, mass flow, right? But when you kind of combined all the things we can do with, the Coriolis meter and the DP and all the other things, you really start to build a really great solution portfolio. So that's been really exciting. But if you're talking about the history of FLEXIM, it was basically 4 really, really smart Germans that were on the wrong side of the Berlin Wall, depending on how you're looking at it. The wall came down, and they all came together. The story I've told is that they all drew straws, and the shortest straw became the CEO.
Oh, wow.
So from there, they kind of put together FLEXIM. We used to have almost, it looked like a really old desktop computer that they would roll around, and it was this big hammer thing.
Wow.
I've only seen pictures of it. I've never actually got my hands on it, but apparently, one of my colleagues down in California has one that still functions, and sometimes he brings it out to sites to do new measurements, which is pretty cool. But yeah, it's, from there, we've been in like a company into itself for a little over 30 years. We've seen a lot of growth in the last like 6 to 8 years. Has kind of been, closer to 12 to 20% year over year growth for us, which has been really exciting. We've done a lot of development for, other ads to what we can do.
Yeah.
And I think that helped, I don't want to say push the ball over the finish line, but, I think Emerson really saw the value in what we did in our core competency, and then all the other things that we can help bring to the table to help supplement what they already do. It kind of was a no-brainer. So
definitely,
selfishly, it's been great.
That's awesome.
I really can't think of a better scenario for a company for us to join. It's been fantastic. So
that's awesome. Yeah, that's like you said. I mean,
thanks, Jens. Good call.
Yeah. It might have been fast for you, but I remember, every year we go down to Emerson and we give our feedback. We have roundtable discussions. We talk about what's going on in the market. What do we see? And for years we've said, hey, you should go buy FLEXIM. And then especially recently, you've seen it more and more pop up. It seems to be, one of the fastest growing flow technologies, just because, what we've noticed too is people are making more measurements, right? They need to capture more data, especially as there's different sustainability related goals that people are trying to hit. The first step is to start monitoring, and that's a very simple step that a lot of people aren't doing, and the FLEXIM presents a really great solution for that. And maybe we'll talk a little bit about what it is, how it works next.
Yep.
But there's some big advantages, and just like you said, I think it totally fills a hole in our portfolio. And now, I'd be hard pressed to find some applications that we can't do with the combination of FLEXIM, micromotion, rose mount. Between the three, we basically have everything that you need.
Yep.
For, let's say, industrial processes, right?
Yep.
There's definitely some other, weird nuanced applications, but for what we do, it's really,
we certainly find the science experiments with us.
That's true. It definitely does open up some of those. So, maybe you could talk to me a little bit about, what the FLEXIM is. Why is it called FLEXIM? What's non-intrusive?
Sure.
Ultrasonic, all that.
I'll start
stuff
with the name. Again, one of the very funny German jokes is that FLEXIM stands for Flexible Industrial Measurement. That's what the IM stands for. So
I didn't know the IM.
So that was what the IM stands for. Again, it absolutely kills in Berlin when you tell that joke. Kills. FLEXIM, we use time of flight is let's call it our backbone, time of flight measurement. With that, we also supplement it with a couple of other different technology. We have a refractive index meter. So we've got a couple of different ways to make measurement. If we're talking about it from a propagation technique, basically it's two transducers, and in its most distilled form, it's two transducers that sit on the pipe that speak back and forth to each other. And when you have that, you have a time of flight. Time of flight allows you to see, information, diagnostics. There's a lot of diagnostics that come from that, sitting on the pipe. You're going to get sound speed. You're going to get signal correlated noise. You're going to get how hard the transducer is working. So, your gain drive for your Coriolis, but for us, it's our very amplitude. So you get a lot of diagnostics from our meter. What FLEXIM has done probably better than anybody else is kind of look at those diagnostics and then extrapolate them into mass flow, into concentration. Taking clamp on gas measurement, which generally speaking is around 120 psi, 130 psi, and we can get down to the 40s and 50s depending on what we're measuring, right?
Yeah.
So we've taken the core concept of ultrasonic clamp-on measurement, and that's all we've done for the last 30 years is develop it, right? So it allows us to use a propagation and a technique that came out a long time ago, promised the moon and the stars to everybody, really didn't deliver.
Gotcha.
Created a lot of scar tissue. I mean, I like to say 50% of my job is when I go out is dealing with the scar tissue from, past ultrasonic measurement that was clamp-on. There's two sides of that coin. Obviously, I love those situations because it's just a great opportunity to go out and put on the pipe and show them kind of like how things have changed in the better part of 30 years. I mean, look at your iPhone, even for 5 years, right? So we've had huge changes from our, computational side of our meter. But yeah, in essence, we clamp onto the pipe. We do a couple of things a little bit differently. So we don't use gel when we're installing our permanent unit. It's always going to be a pad. That's usually a pain point for people. We have a really robust mounting system. So, you have that. Everybody has a visualization or a thought that, clamp on a pipe, it kind of looks, for lack of a better term, janky.
Yeah.
Right. We install and are meant to be in very challenging industrial environments. So you're going to have, IP68 waterproof mounting kits. You're going to have dust proof. You're going to have something that's going to last a really long time, because when we look at installing our meter in a permanent sense, it's almost 90-something% of our sales, right? So everybody believes that we're clamp-on temporary. A large majority of our sales are permanent units.
That's a huge misconception too. When people think of clamp-on ultrasonics, exactly that. They think it's a short temporary measurement, which you can absolutely do.
Absolutely.
And it's fantastic for that. But like you said, it's the permanent installations are really where we see a lot of value. So just going back to a little bit of the basics, just to help visualize those who've not seen this.
Yep.
Basically what you have are at least 2 transducers or a set of transducers, and you could have more. Yep. And what you would do is you'd mount them on opposite sides of the pipe.
It depends. It depends on what you're trying to, if it's liquid, if it's gas, the way you can manipulate where you mount your transducers can help, bring down the pressure. It can help, improve your resolution of your measurement, your low flow measurement. Okay. Right. So we've got the ability to kind of bounce that beam in lots of interesting ways.
But one is upstream, one is downstream, basically, and either opposites or same sides. Yep. And I guess the idea is you're transmitting an ultrasonic signal through the pipe, through the liquid media or gas media, and it's either bouncing off that pipe and coming back to the other transducer, or it's going straight through the pipe to that. Yep. And so when you say time of flight, you're talking about quite literally, you're measuring the transmitted to the received signal.
Correct.
And it's impacted by proportionally to the flow rate, correct?
Yeah. So the flow rate publishes itself actually inside of the transducer. The time of flight in the media is the same, whether it's going upstream or downstream.
Oh, okay.
So that's kind of a big difference for us, is that when you're looking at where we actually create our delta T, it's inside of the transducer and where that signal is received on the piezo crystal inside.
Oh, like physically where?
Yeah. So a lot of other measurement technologies basically are just very expensive stopwatches. Yeah. Right. Where they're timing, there and back, there and back, there and back. And if you're swimming against that current, technically you would create a delta. For us, even if you're in that media, you have still the same sound speed, which allows us to get into the mass flow measurements, because that sound speed is going to be a relationship with temperature and density. So that's going to change. If your temperature goes up, your density changes, your sound speed has a relationship to that. We can see that because we are inside of the transducers doing that delta T measurement. Another thing that we do that helps us with that is we have that RTD that's inside of the transducer head. What that does is it fights drift, right? Drift is something that really affects other measurement technologies and also stops you from being able to do, those, let's say, the heightened side of what time of flight measurement allows you to do. So that's kind of another thing. That's the FLEXIM advantage, for lack of a better term.
Okay, yeah, because so most people would think of ultrasonic, they would think of exactly like you said, either the flow is helping or dampening or slowing down. Yeah. So you look at the change basically in the time as a result of either the flow helping or hurting.
Again, exactly.
Okay, so that's not really what happens here.
Yeah, it's more, we do a time of flight calculation. It's really more of a delta T from where we send the signal, where we receive it inside of the actual transducer head itself. That's cool. That helps us get into those higher accuracy ranges, and then helps, allow us to get into lower pressure gases. It also allows us to get into the mass flow and the other things that we do very well.
So you'd have either maybe a pair or multiple pairs of transducers, and then depending on the setup, that's really how you depending on the sizing parameters and the characteristics of the application, that's what dictates how many transducers, the type of transducers, where the transducers are placed. For sure. And then they have some sort of housing to them depending on the environment, and then that goes back to the transmitter.
Yeah, and then the transmitter itself can be, a different style of housing depending on the environment. So in essence, it's mounting, transducers, and the transmitter itself. So the rule of 3. Okay,
and then the mounting to the pipe, that's another thing. So you mentioned that a little bit already with the gel, right?
Yeah, so that's like the gel. That's the style of mounting brackets that we have. If you're a class 1 Div 1 environment, ATEX, general purpose, we've got different types of mounting. If you're on a plastic pipe, with thermal expansion, we have ones that have like integrated springs that help kind of deal with that expansion. So we've got lots of ways to help make that, measurement as permanent as it can be. Okay. And that's a big importance for us as well.
And the gel, so the gel is that kind of like no different than, going to the doctor and you get an ultrasound?
It's funny you say that. Every time I end up having to send something across the border, it always gets picked up by like, some health related. They're like, hey, can you send us some type of, data set about this? I'm like, trust me, you do not want to put this on a lady's stomach. So it's basically like a couplant. So basically what it's doing is helping remove like impurities in air. So it's really just uniform in creating no air pockets, so that when you're putting your transducers on the pipe,
it's flush.
It's flush.
And so it's not adhesive.
Not really, no. I mean, it's going to be like gel, like it's like your hair gel, for lack of a better term. Like, so there is a little bit of adhesive to it, but you're not going to want to use that as it's mounting itself. It's more of a supplement to it as anything. So you'd have something to go around the pipe to actually clamp it to the pipe in addition to that. Okay. Yeah. That just I don't know. For me, it always helps to visualize what you got going on here. And like you said, right, the wide world of YouTube, we could have, people who have lots of experience. You could have very little. So, when I look at the mounting, generally speaking, it's 2 straps. There's a center chassis that has some type of tension or spring mount that pushes the transducer down.
Gotcha.
So there's and there's one that stops it from movement on its x-axis, its y-axis, so it kind of secures it to the pipe.
So it's not going to move.
Correct. Even inside of the chassis itself, it's locked in as well. Inside of all of our mountings as well, you're going to see ruler or some type of measurement device that you're going to be able to use to get a really accurate cross-sectional area measurement as well.
That's awesome, and that kind of leads into the next point, which is really like what are the advantages, and I think it's very clear. The non-intrusive part, but then maybe talk a little bit also about how long it takes to install.
Yeah, I mean, the big advantages that we're going to have this, generally speaking, cost of installation for us is very, very minimal.
Total cost
of ownership, TCO, is very, very minimal for us. It's from a perspective of maintenance. It's because we use those pads. It's almost non-existent, right? You don't have to worry, even if you clean a pipe or you have to steam it, I always tell a customer, hit it as hard as you want and as often as you want. It really doesn't affect us. And it's actually going to help our measurement in a lot of ways. And we're going to help give you some diagnostics as to when you're going to want to plan the preventative maintenance. Obviously temperature, cryo and extreme heat. So the hottest I've been in Canada is about 620 degrees Celsius. So that's pretty hot.
Yep.
Not a lot of stuff's going to last there. We do really well because, again, we're outside the pipe. Obviously from that as well is high pressure. The highest I've been on is about 2,600 PSI. So that was pretty good. That was a Schedule 160 XXS pipe. So that was a pretty thick pipe that we were on. But that, because you're outside the pipe, you don't have to worry about those complications. The cost alone, putting something, in process there is usually dramatic. So we become a really, really interesting. Obviously, contamination is a big thing as well, depending on the industry, right? If you're, food, pharma, I actually use the term as we're going to cut your paperwork in half, right? So usually when you're saying that to somebody in the food industry, they're like, oh my gosh, thank you so much. So because we're outside the pipe, we don't have to worry about all those, finicky CRNs as some of our colleagues in the States are learning about, the little intricacies of Canada. And the big one for us is the no downtime, right? So the ability for us to kind of go on the pipe, have a really repeatable measurement, even leaving the pre-existing, style of measurement that has failed or has some type of complication, leaving it there and still putting us on the pipe. I love being with Emerson now with the wireless heart, right? Because now you can drop in a measurement and you can send wireless communication from the meter, right, to, our incredibly robust wireless communication and data side of things. And you can start getting so much information, right, about what your process and what's going on, that it's just like, for me, that was the thing I got the most excited about. So those are like the 6 things that, kind of raise where FLEXIM's use cases are.
Yeah.
And, we use those as like our tenants when we're speaking to a customer, like, hey, if you check 2 of those boxes, we're kind of a no-brainer.
Yeah.
And if it's one box, it has to be the right one. Otherwise, we're going to lean on all the other things that Emerson does, better than everybody else. And that's what we'll lead with. So.
Yeah. Well, especially like when you talked about total cost of ownership and like installation, like we witnessed this firsthand where we were doing some training here and we had a nice flow loop that was supposed to arrive. And of course it didn't arrive in time for the training. We thought, what are we going to do? And so thankfully we had a, piping system set up out back, which was like there's nothing in it, and we were able to just throw in some compressed air and very, very low flow for these size of these pipes.
Yep.
And you were able to show the team, clamp onto the outside of it, get the measurement going, and it was quick. It saved the training, and I think that really helped to solidify, like, wow, this is easy, and I can now see we didn't have to damage the unit, we didn't have to cut pipe, we didn't have to install flanges, and so just like you said, depending on the industry or depending on the size, like that's huge, right? I mean, if you have we don't have to go that big; it could be a 12-inch pipe, right? Like even an 8-inch pipe, right? There can be substantial costs. I mean. Most pipes aren't just on the floor, right? So, I mean, you got to put up scaffolding, you have to get scissor lifts, you have to get, and if it's a pressurized system, right? Like, you know, again, talk about CRN, right? You have all of that, those processes involved. So, like, that's where really, it becomes super easy for a customer and they don't have to wait for a shutdown.
No. And that's, you know, as the industry kind of changes and, you know, evolves, I think that, you know, they'll look to have shutdowns as less frequent. Maybe the frequency of those shutdowns or when they're doing their planned maintenance is going to become a little bit longer. Yeah. As, you know, like you say, they start to look to add more measurement because they want to raise that reliability so they can have as much uptime as possible. Yeah. Right. So with that uptime comes, you know, a higher yield. With that higher yield comes a lot of happy stakeholders, right? So they're going to have, and I've seen it in certain industries where they start to elongate that process. It's really great for us, right? Because it's a very easy calculation when you look at the total cost. And like you say, when you're getting up in the 6, 8, 10 inches, it's almost a no-brainer in a lot of ways. And then, you know, we start to look at, you know, where we're going to install it. We do a couple of things with our units, like, you know, the multiple channels. You know, I look at it from, you know, we have the ability to go multiple channels. If you, the end user, doesn't have the ability to find a more ideal scenario for straight run, right? So we can use multiple channels, our profile or disturbance correction, things that we do better than everybody else that allows us to get into those challenging areas.
You brought up a good point, straight run. Yeah. That's something that is one of the first and foremost things everybody asks and they want to know about. So talk to me about straight run. How important is it? What can you do with it? Yeah. What's the recommendations?
Yeah. I mean, you know, the adage is 10-5, right? 10D diameters upstream, you know, 5 downstream. Yep. I look at it like, well, what is your upstream disturbance? You know, if you're a static disturbance, so what I would liken it to, you know, a 90-degree bend, that's a 90-degree bend every day. That's going to be something I'm going to be okay with the 10D, you know, maybe having multiple channels to move us closer. If you're something that's a dynamic, right, you've got a valve that actuates up and down, right? We're changing that flow profile that's coming through that point. We're going to want to have more straight run, generally speaking, to get a better, more a profile that's going to make more sense for our ultrasonic meter, right? Because we are a 3-dimensional space and a 2-dimensional beam cross-section of that space, right? So we look at the Reynolds number, so we're using the Reynolds number to create a flow profile, the flow profile to create a volume, you know, a velocity measurement, cross-sectional area. So there is a lot of smaller things that are kind of add together. And the way I liken it is, my mom's a math teacher, so I always say, like, you know, if you have as much of you compressing any type of errors in your first part of your calculation, you're going to yield a much more accurate measurement at the end. So if you've got more straight run, you're going to get a better flow velocity, you're going to get a better volumetric flow, mass flow, all the other things. So 10-5, we've got the ability to go into scenarios where it's less. Profile and disturbance correction. So we've mapped out those type of disturbances. We have built them into our meter. So we've got like basically a Reynolds conditioning factor that we apply to the measurement. And it really where you're going to find that really effective for us is the lower flow, right? When your Reynolds number is going to be a little bit lower because your flow velocity is a little bit lower, that's where you're going to yield the most amount of success for that.
Okay, that's awesome. So 10-5 general rule, but it can probably be less, which, I mean, it's no different than a mag.
It's no different than any other measurement technology. For whatever reason, we always end up being like, oh, well, and you talk to other technologies and it's like, hey, you know, there's the same rules for mag and Vortex and DP and, you know, well, not Coriolis, but. Yeah.
No, but with like similarly where, like, so mag is we can do 0. Yep. But there's some limitations and there's some caveats and like, and it's like anything, right? Like, I mean, you could do nothing, but like, how is that going to impact things? What's the accuracy? What's the repeatability? And it all depends on the upstream disturbance. Cause like you said, if it's a 90-degree elbow, it's always going to be that. Yeah. But if it's some sort of valve that's moving up and down and changing the flow regime all the time, that's a little bit harder to
We're basically going up against the laws of physics, and they're undefeated in every fight.
Yeah, they'll win.
They're going to win.
Yeah.
So we try to do what we can from a placement perspective that's going to yield a measurement that's as accurate as possible. Even if it isn't in a great spot, it's going to be repeatable, right? So that's the other side of it is like, hey, if you don't have that space, okay, well, maybe you're going to see some inaccuracy from our total accuracy measurement, but we will always be repeatable from that measurement point. And you'll find that a lot of customers, at least that I found, is a lot of customers, once you start to kind of peel the onion for what repeatability actually gives you, they usually are actually seeking out a higher repeatability than a higher overall accuracy. Totally.
Yeah. Like I've said this before on the podcast, and I love saying it, someone in one of our mining customers said, "Hey, would you be that upset if you got 95% on your math test?" You're like, "Oh,
I've never even got a 90 on a math test, and I had a mom as a math teacher, so I will take the 95."
Well, she was harder on you, right?
Well, that's true.
Yeah. She can't show any favoritism, right? And some of these applications, you can't install other things. Like if it's a really big pipe or it's just awkward locations, like you kind of, you'll settle for the repeatability.
Yeah. So. And like you say, when you're getting up into those larger line sizes, generally speaking, measurement was a secondary thought.
Yeah.
Sometimes third, right? And when that is the case, it's about looking at that problem again from that. We get to look at it from the 50,000, the 10,000, and then we drill down on it. So like the customer wants a measurement. Okay, well, here's all the different things. Here's what the value prop for each one of them is. What's your actual want? What are you trying to gain from this measurement, right? And that's, something because we've got such a robust line card now, we can have a much better conversation. And anytime you have a better conversation, you get better data. And if you get better data, you usually get the best results. So it's been really great for us.
That's a good point about what are you doing with this? Because especially as you put a measurement hat on, right? You're like, well, I just got to make the best measurement ever.
Yeah.
But it's like, well, do you have to? Do you always? Like, I remember talking about this in one of our seminars where, I generally will say, most pipes are oversized. Now, what I'm saying is they're oversized for the flow measurement. They're probably not oversized for the person designing the piping system, right? So you have to recognize, well, the primary purpose of pipes is to move around products, right? They have a plant to run. They're making something, right? Yeah. So that's the primary purpose. And you don't want those pipes to be a limiting factor if they want to keep scaling up. So that's the primary purpose. The secondary purpose, or the secondary kind of point you have to consider is, well, we got to be able to control that and to measure that. Yeah. So you got to put in flow meters. You got to do all this sort of thing. So, in a perfect world, I'd like the pipes to be smaller for better flow measurement, but that would defeat the whole purpose of the plant, which is trying to make this stuff, right? And so it's like you have these competing goals, and really the first goal is always going to win. So now that you know the winner, you know the outcome, what are you going to do about it, right? And so that's where you run into these situations where it's about making the best situation work depending on the technology. And so going back to now that you have all these tools in the tool belt, just picking one appropriately, considering all that, right? And considering, well, exactly, maybe they didn't have a measurement here before, and now they're just looking for monitoring, or, hey, this is a critical one for control because it, controls the level in the distillation column or whatever, right? Like different applications have different needs. And if you go into it with just, I want to make the best measurement ever, that's wrong, because that's not the goal of the plant. Is not just to make measurements, right? It's to run the process.
Yeah, so run the process as effectively as well. And another thing too that I've seen is that safety is a big thing.
Yeah.
Let's just say plants built, Canada's got a very rich tradition of having a lot of kind of older plants that have been up and running for a really long time. Like you said, it's that two ideologies of we're building for the now, we're preserving for the future. Safety is a really important thing.
Absolutely.
Right? And the safety side of things is usually extremely hot or extremely dangerous or a lot of pressure, which are all three things that we do really, really well, right? So, we're talking a delay coker, right? That's almost our first, salvo into every refineries, because we do it better than majority of every technology, and we have the longest uptime. So our total cost of ownership for those is fantastic. And on top of that, it's usually the rule of three is being kind of utilized there, and it's from a safety and perspective, it's kind of a critical measurement. So we give a lot of diagnostics for that. So if you kind of look at each problem, you're like, okay, like what are you trying to do here? What's your end goal? Is it safety? Is it this? That's where you start to really kind of pull out the real value of FLEXIM for us. So it's been, like I said, and I'll say it again, it's been really great for us this year.
That's awesome. You kind of talked a little bit about accuracy and repeatability, maybe we could dive a little bit more into what is the accuracy, because that's another question we quite often get to go, well, how good is the measurement really? It's not in the pipe, right? And that's a real thought that people have, whether it's true or not.
Yeah, I mean, again, like it's going to be a challenging thing to argue, like, oh, well, what is the actual accuracy, right? The actual active transit time based measurement is about 0.2%. So if you actually were to look at our calibration certificate, the active, these two transducers talking back and forth to each other, and the accuracy from that is about 0.2%.
Yeah.
When you're looking at it from a liquid perspective, we're going to look at our spec. It's going to say 1%, right? So if you're looking at 0.2, so that other 0.8%, that's all uncertainty of the pipe and the installation, right? We take that into consideration when we stipulate our accuracy and our measurement. But what you will always see is that repeatability will always be the same. Even if somebody, a neophyte who's never installed it, to an expert, like Lucas, shout out to Lucas, who is installing this device, they're going to have some differences in accuracy, but the repeatability measurement between the two will be the same.
Yep.
So, we like to say with liquid-based measurements, you're looking at about 0.15% on the repeatability. For gas, and gas is a little more tricky, so we end up having a little bit of a wider berth for accuracy. It's about 2%, 2 to 3%, depending on the media, and that's because gas from a physics perspective is much different from liquid. So it rolling through the pipe, it tumbling through the pipe. We are a 2-dimensional beam in a 3-dimensional space. So trying to capture that full, flow profile as it travels through is a little bit more of a challenge for us. So we then apply that uncertainty to the measurement. Great. So that is a short way of saying for liquid 1%, and for gas 2 to 3%.
Yeah. Well, it's good. Again, just like the 10-5, it's a rule of thumb, and that's kind of where you understand like where you are, and it's also one of the criteria when you're picking the right technology, right? Like, is that good, right? Like, is that fine? And again, quoting my mining customer, right? That's good for them in some applications, but other applications maybe not, right?
And like you said, it's we have things where we can calibrate a unit to a site. If you're looking at our PIOX units, our mass flow unit, right?
Yeah.
If you wanted to output a very accurate concentration measurement, we can calibrate that unit out in the field. So we can do a timestamp basis, say, hey, the sound speed that we see here, here's your weight percentage. We add that. We basically teach that meter a new version of the accuracy. We can do the same thing with our hydrocarbon, right? So API, when you're putting on a pipe, we can tell it. We can help the meter drill down on that single point cal of whatever that media is. So those are things that we can do to help kind of raise the repeatability. So like out the box accuracy as opposed to after calibration accuracy. So I like to, like you said, cast that longer net where it's like, hey, 1% is a great talking point. Then you start to learn about what this customer is actually doing, where they're installing it. Then you can start to say, hey, if you wanted to get, sub 1%, this is what we need to look at. Does the application and the challenges of that application warrant us going and looking at trying to drill down on the overall accuracy, or are they going to, again, be okay with repeatability? So it's that relationship, that give and take relationship that we can help.
And really what you describe is no different than really any other flow meter. When you install it, there's installation effects to ease-zero out when you first get the meter there, right? Like same sort of thing.
It's so interesting to me because we're clamp-on, we can be put kind of everywhere. People, for whatever reason, that always ends up being kind of a tertiary thought in the back of their head. They don't realize that, like, hey, we are still a meter. We still abide by the same rules that every other measurement technology abides by. I think that changes a little bit now we're part of Emerson because now we have, let's call a spade a spade. And, FLEXIM globally was about 380 people last year. You have more than that with Lakeside.
Yeah.
Right. So we're gonna have a better conduit to have that messaging directly to a customer. Maybe directly to certain customers that we weren't speaking to at a certain, let's call it, level, that helps that message kind of resonate down, right? So that maybe, 3, 5, 7, 10 years from now, the conversations are changing. One of the really cool things, and it's just to get on the sidetrack a little bit, but, Emerson came to our, almost a year ago now, to Berlin. We were all there, and there's a gentleman who basically spoke about the way he looks at ultrasonics and FLEXIM is kind of similarly to where Coriolis was, 20, 25 years ago, where they didn't maybe have the reach they had with customers to kind of really talk about what they can do, right? And so that there's a lot of those correlated effects between the two technologies because, like you said, ultrasonics in general is the fastest growing market vertical for measurement technology. So with that comes a heightened awareness that this is a great technology, that there is a change now from a technological perspective. We're able to do things we weren't able to do. But we still fall into the realm of certain things that are, we can't, compete against. But now we've got the right people situated globally that help talk about that message to people, and hopefully it'll start to resonate. And then the conversations you and I are going to have, 5 years from now are totally different than the ones we're going to have now.
For sure. And now I think you've done a good job articulating at least what the benefit is for us as a Canadian Impact partner and the relationship that benefits FLEXIM and Emerson. Like that to me makes total sense. But for a customer listening, and we've talked a little bit about this, you just mentioned it, so like you said, maybe they had an ultrasonic on site that just wasn't working, right? And maybe this is 5-10 years ago. Maybe you could talk maybe in some detail about some of those advancements that have been made to the technology. Why it is one of the fastest, if not the fastest growing technologies. Like, is it just because, hey, now we're Emerson and we're selling it to you? Or is there actually substance to what's in the technology that wasn't there 20 years ago?
Yeah, I mean, I really think one thing that was for ultrasonics, it came out the gate really hot. Right? Came out, promised a lot, right? They immediately created that that growth for it. And then what happens, it really underdelivered, right? And because it underdelivered, it created a really bad taste in everybody's mouth. So development spending really for that dropped off precipitously, right? So it kind of stymied that growth that we probably would have organically seen. But for FLEXIM, I can look at it from a FLEXIM perspective. So the things that we do, from an ultrasonic perspective is, we have the best amplifiers, right? Filter boards, right? Be able to quiet the noise from process versus the noise from your transducer, right? That allows you to get through challenging medias, that allows you to get into the lower pressures. The advancements just from a computational perspective, right? So maybe 10, 20, 30 years ago, because we didn't have the range of frequency that we were in, a 10D scenario, we really probably should have been more 20 or even 30. So there was a lot of inaccuracies there. Now we're able to kind of, from a computational perspective, we can map out a lot of those, put that into the meter, right? That allows you to kind of be in those challenging areas now. Plus you couple that with, the improvements from a computational perspective, the power, the amplification, all the understanding the diagnostics, I think the diagnostics have been there, right? There just needed to be time to develop what those diagnostics mean on a liquid measurement versus a gas versus a steam versus this. So now we're able to kind of really correlate what those diagnostics mean to a measurement, right? And now we're starting to extrapolate all of the, value from it. So I think that's a big thing.
Well, sorry, I was just going to say, I really see this as an analyst to level transmitters, right? So our FMCW radars, that was the technology, that we invented in the 1970s. And FMCW radars, the technology itself hasn't changed. That the same concepts still apply, but it's a totally different radar that we have today. For the exact same reasons. It's all the computational components, the algorithms, all the microprocessors, all of the details that you, as a customer, you wouldn't really understand it. There's a whole bunch of scientists working on this that would definitely tell you about, all the advancements. But that's where I think kind of it's a lot of this stuff under the hood and the computations that make a lot of the difference. There was something you had mentioned. I don't know if I actually mentioned on the podcast, but I do remember, some of the basic training we had about FLEXIM was it can switch between modes. Right. Maybe you could talk a little bit about that.
Sure. So there's two different last column schools of thought for the ultrasonic. There's the time of flight and then the Doppler. Right?
Yes.
Doppler is another technology that's been around for a long time. So our unit actually utilizes both technologies. So the meter itself will kind of lean transit time first, and in the background is always working in what we call 𝗧𝗓𝗔𝗬, which is kind of like our version of Doppler.
Okay.
So if I were to describe it from a use case scenario, let's say you're installing it and you're operating on a liquid application, and then you have a event of high signal attenuation. So if you're a wastewater, you've got a rain event, you've got a lot of drainage, you've got sticks, twigs. If you're in the city of Toronto, maybe a finger, who knows, coming through the pipe, and that's going to help disrupt that ultrasonic signal. So the meter itself is going to see, hey, we're having a dip in our diagnostics. We're going to then automate and flip over to our 𝗧𝗓𝗧𝗏, Noise check will continue to operate very similar to Doppler. Works really great for those high signal attenuations where you've got particulate or aeration and things like that, where it works fantastic.
Yeah.
And it's going to continue its measurement. In the background, the meter is always looking for transit time signal to return to an area where it's going to have measurement over a certain period of time. You, the user, can actually set that up in the meter. Like, hey, if transit time fails for more than 5 seconds, activate Doppler. If transit time returns for more than 10 seconds after, then switch back to transit time.
Yeah.
So you have the ability to be that flexible, go out in the field and kind of and look at your process, and you hopefully know your process very well. If not, we have really skilled people all over the planet that can really help guide you in that decision. And then we just look at the process and we can make the changes. And then the great thing about it is that it's always on, right? You don't have to go and physically manually touch anything. Again, there's another one where it's like a white cap going out and just putting on a safety helmet to go press a button and out in the field is kind of not a great use of somebody's time.
Totally.
So the meter itself can just do that for you. It'll timestamp when it does that. You can make it send an alarm, hey, I've switched between the two, so the operator can kind of see what's going on. And the way I look at it is you are going to get more insight of what's going on in your process. Right, so you're going to have a time-stamped event. This thing happened. You're going to have other things in your process, whether it's a level or other measurement technologies that are showing similar changes. You can hopefully take that information and start making improvements. So that's a big thing, right? The whole thing about our meter is that it's going to give you a lot of information.
Yeah.
And the goal for me and the goal for, I think, anybody who's engaging with the customer with FLEXIM is to really help them understand what those diagnostics mean so that they can make better decisions.
Yeah, and that's no different than our Coriolis too, where it's like quite often, people will install a Coriolis, and let's say they're upgrading from like a Vortex or something, and they might not like the readings.
Yeah, what a change! Can you imagine?
Yeah, and the reality is, quite often it's telling you something about your process that you probably didn't know before. Yeah. Like quite often, so one of the surefire ways to tell if you have two-phase flow, so if you have like bubbles or slugs of air in your liquid on the Coriolis, is typically your density drops and your drive gain spikes. And your drive gain is how hard the Coriolis is working. Yep. So I always give the analogy, or at least Emerson does. They like to say a basketball half filled with water, and so the Coriolis is constantly shaking the tubes to like the same frequency, basically. Resonance. And the resonance, that's the word. And if it's half filled with water, imagine trying to bounce a basketball. Like you can't do that. So when you have that, that's why drive gain spikes, and then your density drops because it's really looking at the average density of the mixture. So so when you give, instead of 100% water, now it's 50% air, 50% water, that drops. So it's a surefire way to let you know, hey, you probably have two-phase flow. Yep. So many times I can't tell you where you've installed the Coriolis. It's in a good spot. It's where it should be. But suddenly they get these conditions and they go, hey, what the heck's going on? And you go, well, you probably got entrained air. They go, no way. And you're like, I don't know. I think there's a way. Yeah. And sure enough, it's, it tells them that maybe one of their pumps is sucking in some air, or, maybe they have it near a tank and some mixers are agitating air or whatever. There's many ways that entrained air can get in. But so similarly, it's you learn more about your process when you put this in, not just flow rate. Yeah,
and again, I think that's just people become maybe like certain technologies after a certain amount of time, you become a little more acclimated to what it's measuring. What it's measuring and what it's outputting or sometimes can be different. That can be jarring, right? So the great thing about the FLEXIM is that even when we're in those kind of challenging scenarios, we can lean on, the diagnostic values. Right, and we can lean and show them what those diagnostic values mean. And the best part about being clamp-on is they just take it and put it in a different spot, maybe away from where those upsets would be, and it starts to work great. And you're like, okay, well, here it works great, here it doesn't. What's the big difference? And then hopefully it's that learning process, right? It's, guiding them, looking at it, trying to, show where you're going to have those improvements, and then, making those improvements. That's the big thing.
It kind of got me thinking of a fun little story. So Roland Smith is one of our measurement specialists. Shout out to Roland. And he's telling me a story of back in the day when he's working on pneumatic pressure transmitters. Okay. And, these had all these intricate parts, and they're just, really complex devices, right? And, you go fix it, you put it back in the field, install it again. And then the operators are complaining that they didn't like the measurement. And so he said, I'll go out there and hit it. Just tell me what measurement you want. I'll just keep hitting it until you get the measurement you want. Like, Can
you imagine a more rolling story? I don't think you can.
That one killed me. He's like, yeah, well, what do you want? I'll make it. I guess I had all these springs, and I don't know how. I've never seen one maybe I've seen one in the field, but anyways, so
that's a good one. I like that.
Yeah. Which one?
What would make you feel more comfortable? Let me just keep hitting it until it says what you need it to say.
Well, like my version of IT for the computer, right? Give it a smack, turn off and on.
Yeah.
If it's like Nintendo 64, blow on the cartridge. Yeah, that does it.
Yeah, the nickname that I have with some of the group that I have with FLEXIM is that I'm IT James.
Oh, yeah.
Let's put it gently, I'm a little bit younger than some. So I grew up in let's call it a more technical versed world.
Yep.
And I get the occasional IT related question from time to time.
It's going to happen to us though.
Yeah.
It's kind of like you're going to you're paying it forward now because like one day you're going to be like, I'm going
to look at somebody, whippersnapper.
My VR goggles aren't working. And they're like, well, you didn't plug in the Apex unit.
Did you turn it on and off again? I'll be like, you got me.
Like, you can't turn it off. It's nuclear powered. Like, I don't know. Trying to envision the future 30 years from now. Good luck, right?
I'm just trying to get through every day, buddy.
Yeah. So if maybe you could just sum up. So again, for those customers listening, if there's some applications where, besides all the sizing, because we can do the sizing, we can help them as Lakeside, no problem. But like intuitively, maybe there's a few applications that they could think of, hey, this might be a good spot to think about a non-intrusive. Do you have some of those?
Yeah, I mean, I would look at there's spots, and then I would look at from an application perspective.
Yeah.
Right. So for me, the big thing that I look at is, and just because there's just such a prism of importance put to it, is the energy consumption of your process, of what you're doing. Right. So the meter itself could do, an audit of your heat exchangers. Right. So if you've got heat exchangers that run more effectively, it means it's doing a better job. You're going to have a higher yield. Right. Understanding where your consumption is inside of your facility allows you to make better decisions to conserve as much energy as possible. I liked what you said earlier about like, hey, you get good data in, you get good data out, right? So the meter allows you to go out and make those measurements. The same unit can be used on, liquid, compressed gases. It can do BTU measurements, right? So it's got a lot of flexibility, FLEXIM. So
keep using it.
Yeah, it's going to stick. Yeah. So it's got a lot of use cases in that energy space. When I go to a facility and I see things that are going to like totally make sense, right? When you start getting into really large lines, when you start getting into high pressure, when you start getting into things that are really are cost adders for in-process measurement, we become a very easy and simple measurement. Outside of that, then I start looking at what it would take to install a meter. Yeah, right. So
another technology, exactly.
Yeah, or I go into a facility and it's underground, 3 stories underground, and it's a 12-inch line. Well, maybe there's some cost parity between, a mag meter and us on a 12-inch line, but it's 3 stories underground. So moving it is a whole ordeal. And then all the other,
mags are heavy.
Yeah, all the other things associated to do that measurement and to install that measurement, that's where we become really easy. So, the 6 things I say where it's like, those are the advantages. If we check 2 of those boxes, it's almost a no-brainer. Yep. Right? And then we have those conversations like, what is your actual goal with this measurement? What are you trying to do with this measurement? And then from there, we can help refine down. But yeah, large line sizes for sure, high pressure, high temperature. Those are things that are become kind of no-brainers for us.
Super corrosive. Maybe you need some exotic material if it was a Coriolis or...
Yeah, and again, right, we had a really great application in Canada where we were doing, hydrochloric acid for offloading. This is at a nickel facility, and they got a FLEXIM because, we were able to install it a little bit quicker just because of the rarity of the alloy that was used on the Coriolis. So they had their maximize their uptime. Yep. Right. So they were able to start generating more revenue. And then they installed the Coriolis and they have both. So now they've got some check measurement associated to it. Right. So those are the kind of things that you start to kind of open the door and you peek behind the veil about like what makes sense from a FLEXIM perspective. Definitely the corrosive side of things as well. Yeah. Especially when you're getting into the corrosive side of things, and then they're in a remote scenario or remote space, right? And generally speaking, those applications are always kind of linked to the plant's ability to run and make money. Yeah. Right? At the end of the day, they have to make money. Otherwise,
Absolutely.
they're not gonna be there. So, when you find those applications where they're really remote and then they have, a really heightened importance to that measurement, we start to make a lot of sense, right? And then, then we start talking to them like, what are you using it for? Is you using it for balancing? Then you really want that heightened accuracy. That's maybe not going to be the thing for us. Are you using this for, a check measurement? What are you using it for? Then we start to kind of, fill in the gaps of where FLEXIM makes sense.
Yeah, totally. Wow. Well, I definitely learned a lot.
Perfect.
This has been really exciting.
Yeah.
Now, I know you can only share so much because of confidentiality, but I am curious for those listening and are curious, now that FLEXIM's part of the Emerson family, maybe you can shed some light on future developments or where you think things are going, or maybe what customers are asking for, right? So you're not committing to anything.
Yeah. Again, like I said, I'm on 4 on the chart, so I'm pretty low. But I can tell you from a perspective of, let's say Emerson development, obviously, we have a lot of really smart people that do ultrasonics really well. So helping to fill and supplement what we do really well with our custody transfer devices.
Yep.
Right. So having that mind share.
You're talking Rosemount Ultrasonic and FLEXIM Ultrasonic now.
Yeah. Right. And
formerly Daniel Ultrasonic.
Yeah. Formerly Daniel's, talking about, sharing of that information.
That's great.
Back and forth, which is really great. Right. Because all that's going to do is improve both measurements. We've had FLEXIM before Emerson have done a lot of work with like spooled pieces and getting into that flare and vent gas measurement. I think that naturally that's going to be something that we're gonna start looking at because again, it's usually a propagation or a signal technique that was ultrasonic. You guys have it now. You also have the customers where that makes the most amount of sense. Yeah, that's just from me, outside looking in.
Yeah, your perspective.
My perspective is that it kind of makes sense for that to target that and to grow that. Yeah, for sure. I mean, other than that, I think that there's going to be some changes to our transmitter, right? There's going to be some uniformity between some of the other transmitters.
Rosemount blue.
Yeah, Rosemount blue, right?
It's a great color. Maybe.
Yeah, I mean, thankfully it's close enough.
It is
from
pretty
a
close.
Wardrobe perspective.
This is not
me.
red. Yeah, no. Red versus, So, we had that because the Emerson Impact Partner Network kind of all unified in terms of the branding, maybe 5 years ago, 6 years ago now. So we were red before.
Yeah, I've seen a lot of black and red lanyards making their way around. And I was like, hey, was this like a 25-year anniversary?
No.
More importantly, like, how do I get me one of them? But now they're like saying it's from a days gone past.
Yes. So we're all unified. But it's great because it's just everything looks the same and it is the same. Yeah. Right?
I mean, for me, I hope they go down the path of like us sharing that in, knowledge that we have inside of that custody transfer Rosemount space. Yeah. Just because, again, I look at through the Canada prism and the CRN side of things. Yep. I don't want us to also release 2 separate, things.
There should be alignment.
There should be alignment, right?
Totally.
I think that's why there's been such a we had our own R&D path that was independent of Emerson, and obviously being acquired by them. Yep. They're not canceling things, which is really cool, right? And that's awesome. And I commend Emerson for doing that. Like, they understand that we're developing and we're doing things with this.
And you have to.
That we have to. Yeah. We have to grow. You have to develop. That's how you win market share. That's how you win. Yep. Right? So they're starting to supplement maybe what they do or deficiencies they have. And honestly, we have deficiencies too, right? Yep. Emerson does things from a software perspective, from a user interface perspective, from a transmitter. They have the best transmitters. Right, and anybody who says otherwise, they're wrong. Yeah. Right. So for me, I look at that. I'm like, oh wow, this is going to be great. We can start to use what you guys do really well, like communication side of things, integrating what we do inside of that, larger spectrum of what actually needs to happen inside of a plant. I think that's where you're going to see the best synergies for us. I mean, obviously, I think that that's going to be a big thing. Just trying to find spaces for where we make sense inside of that line card. But I really do see the flare measurement. I see the vent gas measurement. I see supplementing and growing what we do in the Rosemount ultrasonic custody transfer space. I see that as kind of like the easier layups. Yeah. And then I think honestly, it just takes some time to kind of find out. After the dust settles, for lack of a better term. Where we fit, and really maybe we find something new that we didn't even know is something that Emerson needs or that we have the ability to do now. And I think it's honestly what we have the ability to do now. That's going to be the real driver for us. So like I said, I'm really excited. Awesome. It's been super exciting for me, just from a personal side of things, because
Yeah.
like, I get to meet all these great people that work for all these impact partners. It's
fun,
and for me too. The best part is that there's such an alignment between how I like to operate and how everybody else likes to operate, which has just made this year really great. And then outside of that, you also working with Emerson, so you've got like the best line card.
Yeah.
Right. So you've got the best products.
You get access to every single customer
and the
every
best
single
product.
site.
And when you're with the best products, right, it just makes the job way more fun, right? Because you're not trying to go out and position something that's snake oil. You're trying to go out there and really help somebody with their actual problems. And there's that gratification you get from, call me old fashioned, but man, I love that part. It's the best.
Well, it doesn't feel like sales, right?
Nope.
It's we're just trying to find the right solution for you, help you out. Yeah. And we're going to do it. I don't, whether it's FLEXIM, rose mount, micromotion, like we're going to help you with it, right?
Yeah. So that's the best part.
That's awesome. So for those listening who want to learn more about FLEXIM, maybe you can point to them some resources, or if they want to get a hold of you on LinkedIn or something.
Sure. So you can reach out to me. You could message me on LinkedIn, James Green. I'm the only one for FLEXIM in Canada. So if you just filter into Canada, you should find me pretty quick. Emerson, we've moved over FLEXIM now into the Emerson website. So you've actually go onto the emerson.com. You can go and find the FLEXIM information. I would say as well, we have some pretty interesting videos on our YouTube page that will show you a lot. They will not be, let's say, as user engaging as the conversations you and I are having or other things, but they're very content rich.
They get to the point of what you need to know.
And you know what?
Yeah.
Describe to me something more German than that. It really gets to the point, right? So it's a really great way of kind of, opening up maybe an understanding of what FLEXIM does, so that, when you have conversations with maybe other ultrasonic measurements, you can kind of see, hey, okay, this is what the differentiators are. And then it's just every time you have a conversation with somebody and they have a little more information about what they're trying to get out of it, it makes the conversation so much more useful. So definitely, hop on YouTube. You can absolutely reach out to me on LinkedIn. No problem answering lots of questions, pointing you in the right direction, sharing the resources. I'm relatively reachable. Yeah, I would say that as well. I love having these conversations. I love going out and talking to people. I love going on the pipe and doing demos. So I would really invite people, if they have any questions or anything like that, just reach out to me or reach out to Lakeside or wherever you are in Canada. Find your impact partner, and we'll more than happy to help you answer any question you need.
Awesome. Well, thank you, James.
I really appreciate it.
Enjoyed the conversation. Learned a lot. Hopefully everybody else did as well. Thanks for coming out, and hopefully we'll get you on pretty soon again.
Episode 24?
Maybe sooner.
Well, okay. I got to get on here twice. I know. Is Logan on here
Logan's
twice?
been on twice.
Logan's been on here twice. That's the bar.
Well, you got to have at least 3.
Oh, yeah.
Yeah.
I'm local, so you can just fill me in on a Tuesday if it's a little bit light.
Yeah, exactly. Cool.
Perfect.
All right. Well, thank you so much.
Appreciate it.